Mr. Taru, in this algebra lesson, we are going to be defining and looking at the graphical attributes of quadratic functions. And this is just going to be a lesson about, well, just mainly the graphical attributes. What are the intervals when we graph a quadratic function? What are the intervals where the function is increasing and decreasing? Are there any minimums or maximums? What's the domain and range? And ultimately, we're going to be plotting a graph of a quadratic function just with a t-table. We don't have any very many tools in our toolbox for knowing how to graph these types of functions. That's going to come up later in our studies of algebra. And indeed, quadratic functions come up in algebra. You're going to study them in geometry. You're going to study them in algebra 2, pre-calculus, even calculus and beyond. And the reason why quadratic functions are such a common topic of study in math classes can be answered with this question. What do these three things have in common? The flight path of that yellow ball, and hopefully I don't step on that now. The reflector at the head of this flashlight that allows the light to be focused on a very small point, or the picture of these satellites. Well, they're all parabolic in shape, and that is what the graph of a quadratic function is. It's a parabola. And it's got a lot of special properties. I'll include a link if you want to learn more about parabolas, and you're going to learn more about parabolas as we study through math up here if you would like to, just extend this lesson. But that's beyond the scope of where we are right now. Okay, so let's just look at what a quadratic function is. We got some definitions of polynomials and what the degree of a polynomial here is. We'll move into the fact that they, develop graphs of, or the graphs are, parabolas, and then we'll look at domain and range and increasing and decreasing intervals and such. Okay, so a quadratic function is a polynomial function of the form f of x. Remember, this is our function notation. This is an expression for y, our dependent variable, is equal to ax squared plus bx plus c, where a, b, and c are all real numbers. So what that means is when you have this kind of question in your textbook or in your homework or just in your class discussions, you're going to know what the values of a, b, and c are. They're variables, but in our definition, they're real numbers. That we'll know that we'll see a 3 here, or maybe a 2 here, and a 5 there, or something like that. Where a is not equal to 0, the coefficient of the squared term cannot be equal to 0, because anything times 0 is 0, and then that squared term would be gone, and we would just be looking at a polynomial with a degree of 1, or a linear function. The degree of this quadratic equation is going to be equal to 2. If you have a polynomial where there's only one independent variable, then we're just going to look at that highest exponent, and if we see that that highest exponent is 2 and there's only one exponent of 2 in there, then we know that we're going to have a quadratic function. Now, just to make sure that you totally understand what the definition of a polynomial is and what the definition of degree is before we move on, because really vocab is very important in mathematics. To understand what's really going on, you want to make sure that you understand what any math question, like a question on a test, is asking of you or asking you to do from the vocabulary that's in it. So a polynomial is a single term or the sum of two or more terms. Well, sum makes it sound like all you can see is addition, but you can add a negative number. So basically, your terms are going to be separated by addition and subtraction, adding by a negative number. And a term is like 3 or 2x or 5x squared, and maybe there can even be another variable like y. A term is a collection of constants, numbers, and variables which are multiplied, multiplied together. You can see some division as well in those terms, but the terms are separated by addition and subtraction. Now, for it to be a polynomial, the exponents that are on those terms have to be whole numbers, 0, 1, 2, 3, 4, and such. You can't have exponents which are decimals. You can't have exponents which are negative once you're in simplified form, if you will. So in other words, if this were a term like 3 over x squared, which can be written as 3 times x to the negative 2 power, that would not be considered, they're terms, but it would not be considered a polynomial because we either have a division of a variable, with that x squared in the denominator. If we bring that up, it would be x to the negative 2. And you can't have negative exponents for something to be defined as a polynomial. And again, I'm at the beginning of teaching algebra, and there's so much stuff that you need to know and you will learn eventually. It's kind of hard. I'm finding it kind of hard to get these lessons together because there's so much I want to talk about. So if you want to learn some more about negative exponents, I'll put a link to that lesson down in the description of this video. And you'll also see all the other lessons I've done so far dealing with parabolas down in the description of this video to further your understanding of parabolas and why we care so much about quadratic functions, and where you'll learn this again or use this again later in your math studies, because we're just in the beginning of Algebra 1. If a is not equal to 0, the degree of a times x sub n, now we're looking at a term with there's only basically one variable in here, because we're going to see what a is, and we'll have a number in here as our exponent, so it might be like 5x to the third. If your term looks like that, then your degree is just going to be that variable. So we have a constant whose degree is going to be 0. We have a term here with an exponent of 1, so the degree of that term is 1, and the degree of this term is equal to 2. Now, later on in our studies, you'll have equations and it could even be polynomials where each of these terms have more than just one variable in them, and in that case we'll have to take those exponents and add them. When those variables are being multiplied together, we'll take those exponents and add them to find the degree of each of those terms. But again, I'm just sort of talking about ultimately things you will be studying as we continue through algebra and geometry and algebra 2 and so on. The degree of a non-zero constant is 0, so the degree of a constant is just a number, so the degree of 7 would be 0. Like the degree of this constant here, c, is going to be 0. If your number is 0, that has no defined degree, and the degree of a polynomial is the greatest degree of all of the terms. So the degree of this quadratic, that's why I'm saying that the degree is 2, because that's the highest exponent that I see in this polynomial with all these whole number exponents. Okay, so a lot of vocabulary thrown at you there at once. I'm not sure if all of that's going to be in the section of your textbook that you're using or working in, but it will come up eventually in your studies. Within each parabola, in the form of y is equal to ax squared plus bx plus c, and I specifically say in this form because this is, well, some books will call this general form, some books will call this standard form. You're also going to learn something called another standard form that doesn't look like this. You're going to learn something called vertex form. There's all different ways of writing the equation of a parabola, but when it's in this form where y is the dependent variable and x is the independent, there will be, sorry about the dog barking, an interval where the function is increasing and decreasing. When we have equations, quadratic equations in this form, y dependent, x independent, 1 power of 2, the parabola is either going to open up or down. And so we can see an interval where the function's decreasing. X is getting bigger and the y's are getting smaller. And then as we continue to read left to right along the x-axis, now there's an interval where as x is increasing, the y's are starting to increase. So we have a decreasing interval and an increasing interval. The vertex will separate these intervals along the x-axis. So when you're looking at a parabola, the lowest or the highest point, when the parabolas are opening up or down, we can turn those sideways too, you're going to learn that later in your math studies as well, that lowest or highest point is going to be the vertex of that parabola. And we're not breaking down and picking apart and really trying to learn all the characteristics of parabolas, but there's a lot of special things going on with that vertex and how it's related to the overall parabola. But for right now, I'm just going to point that that's the vertex. The vertex will separate these intervals along the x-axis. When you're looking for identifying intervals of increasing and decreasing on a function, I don't want to hear about the y values. I want to hear about where along the x value is the graph going down or is the graph going up. Don't mention the y values when you're talking about intervals of increasing and decreasing. And the x-coordinate of your vertex, when it's in this form, is going to be found by doing negative b, taking the opposite of that coefficient of the single degree term, and dividing it by 2a, and a is the coefficient of the squared term. And then in function notation, the vertex itself, the coordinate of that point, you need an x and a y. Well, the x we just said, negative b over 2a. And the y coordinate in function notation is going to be f of negative b over 2a. Just take that, just take that value of x and plug it into the function and find y. The end behavior is the same to the left and the right. The end behavior, what's the graph doing as x goes to negative infinity and x goes to positive infinity? The end behavior on a parabola, and again, we're just in Algebra 1 and we're only looking at parabolas, but indeed any polynomial with an even degree, like the 2, 4, 6, 8, 10, and so on, the end behavior, it's going to go up to the left and up to the right. The end behavior, that means it's going to be the same. It's not going up to the right and then down, did I just say that wrong? Up to the left and down to the right, where the end behavior is in opposite directions. The end behavior is always the same with, parabolas and any polynomial with an even degree. We are going to eventually learn how to graph polynomials of higher degree. That just means higher than a degree of 2. So it's either up to the left, up to the right, or down to the left and down to the right. And not that we're learning about transformations yet, but when that parabola opens down, it's going to open down when the a coefficient is negative. Just a little sneak peek of what you'll eventually learn. Domain is all real numbers. What values of x are included in all of the points of our graph? This parabola is made up of an infinite number of points. What x values are included in each of those x, y, and coordinates, if you could identify each one of those individually? All of them. Parabolas open, at least in this form, right here. Parabolas open up or down, and they will expand horizontally forever. So the domain is going to be all real numbers. Every value of x can be plugged into this equation, and this equation will be defined. You'll get an answer. The range will be limited by where the vertex is and whether the parabola opens up or down. So let's see, where do I have? I guess I have a little bit of room to write over here. When I look at this graph, the range, again, is about the y values, and the lowest y value for this example would be whatever the y value is for that vertex, and then the graph from there goes up forever. So the range, is going to be like y is greater than or equal to whatever that number is. So if that y value is 4, the range is going to be y is greater than or equal to 4, because from the y value 4 it goes up forever. So, and I sometimes in my lessons on YouTube, students will ask me to do a video on finding, identifying range. Well, that's pretty much what I do. I really feel that it's best to draw a picture of the graph and graphically, and look at that graph to identify the range, as opposed to just looking at the equation and trying to figure out what that range is going to be. So that's what we're covering. I definitely, hopefully gave you an idea of why you're learning quadratics, why parabolas are so important, and where you're going to see this eventually later in your studies. Oh, and by the way, parabolas are a type of conic section. I'll include a picture here and a link to that video as well. Where in pre-calculus or Algebra 2, when you study conic sections, you'll be looking at parabolas there again as well. And I'll also talk more about why the light out of that reflector came out as such a small little dish of light, and why you're probably getting this signal at some point through a parabolic dish, a satellite. What is it about that shape that makes them so special, and why are satellites, shaped? Can be modeled, the shape of those satellite dishes can be modeled with parabolas, or basically quadratic functions. But for now, we are going to graph a parabola that is in this form, this what my pre-calculus book calls general form, but maybe your algebra book calls standard form. We're going to make a graph with a t-table, and then from that graph identify domain, range, max, mins, intervals of increasing and decreasing and such. So here we go. Alrighty then. Graph f of x is equal to x squared minus 2x plus 3, and then identify what's the domain, what's the range, where is the absolute maximum or minimum if one exists, and are there increasing, or identify the intervals where the function is increasing or decreasing. Well, we just saw this form on the previous screen in general form, and it's ax squared plus bx plus c. So looking at this equation, we can identify that a is the coefficient of that squared term, so a is equal to 1. There's nothing there, so we can assume it's a 1, because when you multiply by 1, nothing changes. So it's the identity property for multiplication and division. The coefficient of our single degree term is -2, so b is going to be equal to -2, and c is equal to 3. So we said that the x-coordinate of the vertex is found by calculating -b over 2a. So the x of the vertex is equal to -b over 2a. Well, maybe I should have wrote a b there as well. -b over 2a. And then when you set up to do your substitution, I want you to not even think about what a, b, c, whatever it is that you're dealing with. Don't even look at the problem. It's just -b, or the opposite of b, I really should be saying, over 2a. Then look at your equation, or look at what you've pulled off to the side and identified of a, b, and c, and plug in the numbers. The opposite of b, well, b is -2. So we have a negative sign from the formula that I gave you on the previous screen, and really it's bothering me that I haven't written it. Let's do that. There, that's better. We have a negative sign, or an opposite sign, from the formula, and another negative sign coming in from our equation. That way, with just writing the parentheses without even looking at the numbers, hopefully you will not make that mistake of only missing one of your signs. Over 2a, and a was equal to 1. Well, that comes out to be this negative and this negative cancel out, or they multiply together and create a positive 2 over 2, which comes out to be 1. So the x-coordinate of our vertex is equal to 1. And we're going to set up a t-table now to come up with some points that I can then draw this parabola through and get a sketch of what it looks like so we can answer these questions. Again, parabolas, and I'm extending the lesson that is in my algebra book because I'm really only supposed to be like giving you a picture and then identifying the attributes from it. Did you notice how those parabolas, so hopefully you're okay with me kind of extending this a little bit and maybe over-explaining it some, or explaining some stuff that you will be exposed to later in your math studies. Those parabolas are symmetric. When that parabola was opening up, it came down to the vertex and opened up to the other side. It was, I didn't talk about symmetry, but if you folded that parabola where the vertex is, where that bottom is, the two sides would line up. There's symmetry there. So when I create this table to come up with some points to connect and draw our parabola, I'm going to have the x of the vertex be the center number. And then I'm going to pick two numbers that are less than that and two numbers that are bigger. And I'm just going to do something easy. I'm just going to count by 1. So if we're on the number line, we have a number line here. If we're at an x value of 1 and we go back 1, we have an x value of 0, and back 1 again, we're at an x value of -1. So I'm going to use the x values of -1 and 0, just counting by 1. -1, 0, 1, and then 2 and 3. And I'm going to put a little v here to remind myself that that's the x-coordinate of the vertex. And I don't know if this parabola is going to open up or down, because really we don't know that much about parabolas yet. We're learning about just identifying characteristics of the graph of quadratic functions. I'm going to take these values that I'm putting in for x, and notice I took out the function notation, just replaced f of x with y. My function is something squared, x squared, something squared minus 2 times that something plus 3. X squared minus 2x plus 3. But a variable, an x is just a place to put in a number, an empty place to put in a number. Or later we'll be getting more fancy and putting in other expressions in there and working out some more sophisticated algebra. But for now, I'm just plugging in numbers. And first I'm going to plug in -1 everywhere there's an x, and then I'm going to plug in 0. And then I'm going to plug in 1, the x of our vertex. But you'll notice I'm actually not even looking at what I'm plugging in. I'm just putting some empty parentheses everywhere there's an x, and hopefully avoid making any sign errors. Now, first time x is -1, then x is going to become 0, and then 1, and then 2, and then 3. Okay, -1, I'm going to put the work for this down here and then erase it in a second so I have some more room to work. -1 squared is -1 times -1. That negative being wrapped in the parentheses, and it needs to be wrapped in the parentheses. The power of 2 is going to affect or be applied to that negative, and we get -1 times -1, which will come out to be +1. -2 times -1 is going to be +2, and then we have the +3. Well, again, -1 times -1, the whole -1 being wrapped in the parentheses and have that power of 2 applied to it, is going to be equal to 1. -1 times -1 is 1, +2, +3, and when you add all that together, you get the y value. Remember, we're going to plug in these values of x and get a y value. So the y coordinate that goes along with the x coordinate of -1 is equal to 6. Now, doing the same thing with our value of 0, anything, 0 times 0 is 0, -2 times 0 is 0, and we're just left with 3. Working here, we have -1 squared is 1, -2 times 1 is -2, and +3. Well, 1 minus 2 is going to be -1, and then +3, 1, 2, 3 is going to be equal to 2. I'm showing a little bit of work on the number line there for combining these positive and negative numbers. So +1 minus 2 is -1, -1 plus 3 is equal to 2. And then we got 2 times 2 is 4, and -2 times 2 is also, well, not also, but it's going to be -4. And then we have +3. Well, 4 minus 4 is going to be equal to 0, right? If we're 4 on the number line, +4 on the number line, and then we move left 4, we're at 0, and then +3 moves us back to 3. And then finally we have 3 squared is going to be 9. -2 times 3 is -6, and then +3. 9 minus 6 is going to be 3, and then +3 is going to be 6 again. Now, I talked about symmetry in parabolas that are the graph of these quadratic functions, and from the x of the vertex, I counted in an even fashion to the left and to the right of 1, or again to the left and to the right of 1. So you can see that the y values, hopefully you see the pattern where I'm getting the same y value, and that's a way of checking my work. If I make the vertex coordinate the center of my t-table, and I evenly count smaller and greater, I should see in my work that I'm getting these right answers. And don't just do half of it and just go, oh, those other two answers are 3 and 6. I mean, I could have made a mistake with my -1, and then when I plugged in +3, I could check my own work and see that, oh yeah, I got 6 again, so I validated my own work. Now, plotting these points, these are x and y coordinates, -1, 6. So I'm going to move, what color do I want to use? Purple. I'm going to move, I'll use white. I'm going to move left 1 because my x is negative, and up 6. So left 1 and up 6, make a dot. 0, 3, that means don't move left and right at all, but just go up 3. So from the origin, don't move left and right, just go up to 3. At 1, 2, we're going to go from the origin right 1 and up 2. So right 1 and up 2. Move right 2 and up 3. 1, 2, 1, 2, 3. And then go to the right 3 and up 6. So 1, 2, 3, and 1, 2, 3, 4, 5, and 6. And the sketch of our parabola, please don't make it a bunch of straight lines and have it be a V. There is a smooth curve at the bottom. That's going to be a sketch of our parabola. Now, that's sort of, again, beyond the scope of where my Algebra 1 book is at. Maybe you were enjoying this, maybe you've already seen this, maybe not, I don't know, because we're all using different books if you're using my videos to help you study. But that is the graph. Now that is the graph of our quadratic function, our polynomial with a degree of 2. Let's use this and answer these questions. What's the domain? Again, it's going left and right forever, so the domain is going to be all real numbers. You might see the words all real numbers. You might see that x is greater than negative infinity and less than positive infinity. Or if your teacher / book is using interval notation, you'll see it as negative infinity to positive infinity. And I like to just have a little x colon in front of that interval notation just so I make sure that my kids realize, yeah, the domain are the x's. The range. What y values do we have here? Now, this point is the vertex, by the way. Again, that bottom of the parabola, or top if it's opening down. And this point is actually kind of something special too, because the x-coordinate is 0. When your x-coordinate is 0, the y-coordinate is going to be your y-intercept. So some students will look at this when I'm asking for range and say, well, the range is 3, but they're not identifying the range, they're identifying the y-intercept. They know range has something to do with y, so they think y-intercept, and they go, the range is 3. No, 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 no. The range is, what y value is included in all of the individual points that are making up that graph. So from this vertex all the way up to infinity, as you move up, that y value is going to change, get bigger, 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 to infinity and beyond. So the range is going to be y is greater than or equal to, well, the smallest y value is 2, and then less than infinity. Now, infinity is a sort of theorized or ideal number, and thus we can't use an equal sign. So that would be what your range would look like if you were using inequality notation. If you were using interval notation, okay, stop barking. Then you'll see that answer written like this. And I like to include the y. We've got positive 2 to infinity, and that's what your answer for the range would look like if your book is using interval notation. My algebra book is using inequality notation, so the answer would be written like it was just a second ago. Absolute maximum value. What is the largest y value that is included in this graph? It goes up forever, so it doesn't have an absolute real maximum value, so there is none. What is the absolute minimum? What is the absolute smallest y value that's included in that graph? Well, the smallest y value is 2, but I also want to know where is that minimum occurring. So we have a absolute minimum of 2 at the x value of 1. Okay? And we can see that here as well. So we have an absolute minimum of 2 at x equals 1. But this is the minimum value, 2. Where's the function decreasing? Where, as you read left to right, read a graph like you read a book, at least in English. I know there's a couple languages that read in different directions, but as you read your graph left to right, as x increases, where are the y values getting smaller? Well, we can see the graph. I know there's an arrow going up to the right, but we need to read this left to right. We're going down, and the y values are getting smaller until we get to this point of 1, 2. So it's decreasing from where x is going to be greater than negative infinity and less than 2, right? Oh, excuse me, not less than 2. I'm looking at the y value, which I told you not to do. It's going to be decreasing from negative infinity up until you get to the x value of 1. So that's what the answer is going to look like if you're using inequality notation, and if you're using interval notation, negative infinity to 1. Where's the function increasing? The function is going to be increasing from where the y value is getting bigger as x increases. Well, the graph is either going down to the right or it's going up to the right. There's no other interval, so it's going to be increasing from 1 to infinity, and that's going to be x is greater than 1 to infinity, or from 1 to infinity. Now, we all are learning from different textbooks, and sometimes authors don't exactly agree on all these definitions. My book many of my books would not be saying that the function is either decreasing or increasing at 1. Okay, I said x is less than 1 and x is greater than 1 for my intervals. Some textbooks would include an equal sign. If yours does, just be consistent with your book and what your teacher, how your teacher is defining these intervals of increasing and decreasing functions. And well, that is the end of my lesson. So hopefully now you understand why quadratics are so important, why you're going to study parabolas so often. But the main point of this lesson: identify from a graph what's the domain, what's the range, what are the absolute max and mins, and what are the intervals of increasing and decreasing functions. I'm Mr. Taru. Bam! Go do your homework.